Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. We are from Group 7, and today we are going to present our STORM project. Before that, let me introduce myself. My name is Siti Suhaila binti Muhammad Akbar, and my matrix number is 200528. I will present about the first part of our project, which is abstract. Ladies and gentlemen, hurricanes are among the most powerful storms in nature, and they can cause inland flooding, tornadoes, storm surge inundation, and heavy rainfall. Due to that, the damages happen after the hurricanes are huge and awful, which needs a thorough analysis. And this analysis is then done by using GIS. And according to FASA 2008, the growth of computer technology has resulted in spatial information technology, and geography, like other courses, requires the use of information technology to obtain access additional sources of information and to aid in the handling, presentation, and analysis of geographical data. Related to this technology use, this STORM project is about hurricane that hit the Upper Texas coast on September 13, 2008, which is destroy the parts of Galveston Island, Bolivar Peninsula, and the Surfside area. Many researchers have conducted studies which showing that the surrounding wetland and salt marsh vegetation reduces storm damages and deaths. For example, during Hurricane Katrina 2005, Cyclone Nargis 2008, and Indian Ocean Tsunami 2004. However, others have also shown that these studies are in error as they do not consider such factors as the elevation of the landscape, the distance of damaged buildings from the shore, and many more. Hence, this project is done to discuss the factors that contribute to the errors in the study. With the help of GIS technology and ArcMap of 10.8 and the application, the analysis of before and after the storm is done and discussed. That's all from me. Next part will be presented by Haikal.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Idam Haikal bin Amri, matrix number 200813. I will proceed the introduction for this project. So firstly, we need to know what is GIS. GIS or Geographic Information System is an information system that implies data related to the positions of the Earth's surface by capturing, storing, checking, and displaying it in order to provide descriptive information of all type of data. GIS can be used to record and analyze data regarding the Earth's surface, create layer maps, chart or 3D models of geographical features that can be manipulated by the user. Okay. GIS also can make use of any type of data, including location, in ways such as latitude and longitude, address or zip code, or in short, we call it spatial data. So what is spatial data? It is made of relative geographic information about the Earth, features that can be made use as a location. There are two types of spatial data, which is classified according to their storing technique. First one is raster data and vector data. So using the GIS technology, the users can compare location of different things so that they can discover how these things are related to each other. So one of the applications that are available online that use GIS is Arcgis. So this is the picture of the application. It makes use of the latest cloud technology system to store information and analyze solution. It applies comprehensive system that were used by multiple academic institutions as well as private and governmental organizations. Arcgis can visualize the geographical statistics through layers of maps that were lined up by the program to create a complete and complex data map. It also provides comprehensive flexibility for the users to define and model the geographic features to their own taste. So next, my friend will proceed with the methodology. Thank you.
So moving on to methodology and result, I will present about this one. My name is Hasana binti Johari. My metric number is 200999. So for the first step, I will explain what this one. I combine step 1 and step 2. For step 1, we have to put the after storm imagery into the map. And then for step 2, we have to put the before storm imagery. So we will have these picture as the output. And then for step 3 is about house image on a scale from 0 to 10, which we can see here my houses that I pointed. I pointed 389 houses using the before storm imagery. And then I have to add field in the attribute table named if damage and put the scale 1 by 1, as you can see here. So 0 is represent houses that has no damage, and 10 is houses that has been totally damaged. So as you can see here, for example, this one is considered as 0. And then for step 4, the damage estimation using parcels. So yes, we are using the parcel 2008 and 2009. So both of the parcel will be added to the maps, and we will have this kind of picture if we set it zoom to layer vision. And then from the parcel that we have put, we want to analyze these 3 things: bulk, length, IMP, and thought. So length is about the value of the land in 2008, and IMP is the value of improvement, the houses or other constructed building, and thought is the total. So same goes to our parcel 2009. We want to look at these 3 things. The same thing in step 4, we want to join in the values from each review parcel file based upon spatial components to the housing points. So this is just steps of doing that. And then for step 5 is about the distance to the shore for each houses. First, I digitize the shorelines here, the starting point and the end points here. And then using the grid features and constructions tool as line. So this is the shoreline, the blue line. And then from that, we want to measure the distance, the houses and the shoreline. So we put input feature as houses G7, and then near feature is shoreline, and then we will get the distance like this one. So this one is the distance between the houses and shoreline in attribute table. And then we want to locate the center, the location where the storm center met landfall on the coast. So we will put this coordinate, XY coordinate into the notepad, and then we bring to this one, and then we will get this center here. And then data X and Y will be exported to a component file called Ecenter shapefile. So for step 7 and 8, both is about land cover LLC, but in 10 meter and 50 meter. So for this one, is the houses D7 are buffered by 10 meter, and then this one by 50 meter. So you can see the different sizes. And then we have factorials LLC that is being zoomed to layer. And then the difference between these two is this one is using 1 color, and then this one has been changed to the grid color, and we add all values. As you can see here, we have 6 colors here. So this is my first try, and second try, and third try. And then after that, we back up the factorials LLC and name it as vectorized LLC project. and this one has been intersected with buff 10. So this one is using the buff 50. So from both buff 10 and 50 meter, we will get the area for each polygon in adjacency buff 10 intersect. So for step 9 is related to LiDAR data. This file is converted from DM to raster, digital elevation models to raster for B, and this one for C, and last one for D. So we will just want to look at, make sure this one in the black white color. So that is all the steps that we managed to do. We will proceed to our discussion.
Okay, thank you for the presenters. For the next one, I will present about discussion. Let me introduce myself. My name is Muhammad Shamim bin Aris. My meeting number is 2011-99. So I will present about the discussion about what we have got based on the project that we did before. So we're going to the next slide here. So this is a graph or the scatter about the house number versus the damaged house rating. As we know that we have did the rating of the damaged house is about from 0 to 10 or 1 to 10 actually. So as we can see here, most of the point have the rating from number 3 until number 10. Even the number 10 is not much as another point, but we can see there. And some of the houses, there are no damage here. We use that as a 0. So we go into the next slide. So as we can see, there were 389 houses detected before the storm happened. So as we can make the based on the graph, we can say that the factor of the difference in house damage rates is two things: elevation of the area, and another one is I'm sorry. The factor of the different houses damage rate is elevation of the area. As we know, most of the damaged houses are from the less elevation of the ground, while the amount of damaged houses on the higher elevation are less. So we can say that this happened because of the development of the soil and causes the decreasing height of the elevation. While the highest elevation happened because there is no any development of the soil. The damage of the house mostly near the center of the storm and also nearest to the shoreline. So we can say that less damaged house have some benefit of the elevation, and they are far from the shore and also far from the center of the storm. So that's what is discussion, and we can conclude based on what we did in the project. So to summarize this project, the factor of the difference in house damage, the house damage rate is the elevation of the area. The majority of the damaged houses, as I said, are lower ground elevation with the fewer damaged housing or the high ground elevation. The next, we can observe that the house damage range from the 3 to 10 on the scale of 1 to 10, as I said before at the explanation about the graph. The majority of the damage is concentrated in the storm center and along the shorelines. There is two things we talk. The first is elevation, and the second one is the shoreline. With a DGPS, with the GIS approach, we can find the data to represent the result that we have got. So I think that's all from me, and that's all from us. Thank you for listening.